Hello, my dear students and my dear friends. So, coming back to where we left in the last lectures of motion, today we will discuss about these terms: speed, velocity, and difference between these two terms, then acceleration and retardation. Right? So, first of all, we will start with our first term, that is speed. Generally, whenever we go for a walk or by foot, then we take our speed as, say, 1 kilometer per hour or 2 kilometer per hour. When we go on a bike or a car, we take our speed somewhat faster, like 20 kilometer per hour, 40 kilometer per hour, 60 kilometer, 80 kilometer per hour. Generally, we talk like that. So, when we say the speed is 80 kilometer per hour, what does this mean? From this sentence, we will find the definition of speed, right? When we say 80 kilometer per hour, an object is moving with the speed of 80 kilometer per hour. It simply means that it covers 80 kilometers in an hour. So, in 1 hour, distance covered is 80 kilometer. So it's clear from this sentence that speed is nothing but distance divided by time. So we can say, we can define speed. Speed as is defined as basically the distance traveled by an object in unit time, right? So if we talk about the units of this quantity, this is a physical quantity. Naturally, it is a scalar quantity, I have told you in the last lectures. So what is the unit of speed? Unit of speed is kilometer per hour. Other unit is meter per second, right? Then some another unit is centimeter per second. What are these units actually? This is a system of units which is known as SI system of units. And this is CGS system of units. SI is international system. Actually, there is a conference on weight and measure in France, Paris, and there is a department. They define the units, right? In whenever you will go to 11th class, you will learn how the units, how the standards are defined. You cannot say that this is 1 kilogram. A 1 kilogram mass prototype is kept in France, and the equivalent is in each and every country. So it means there is a standard which do not change with the atmospheric conditions. So that value is called as a unit. So that SI system is a kind of system of units which we will discuss in our next lectures when we will covering the syllabus of 11th class. So in SI system of units, the unit of speed is meter per second, okay? And in CGS system, CGS is centimeter gram second. So length will be measured in centimeters, mass will be measured in grams, and time will be measured in seconds. In SI system, length is measured in meters, and in CGS system, length is measured in centimeters. It is a difference. Then time is in second, time is in second, same. But as far as mass is concerned, here mass is taken in kilograms and here mass is taken in grams. That is why it is CGS, G for grams. Okay. So anyway, this is not here required to let you know, but still I am telling you, because when we will covering the syllabus of 10 plus 1, mean 11th class of India syllabus, or even other either other schools board syllabus, then we will be requiring this system of units. Okay, then we will throw some light on this. So what is speed basically? So speed is nothing but it's a physical quantity which describes the motion in such a way that it describes how much distance is covered in a unit time, right? So when we talk about speed, then there is another term which is known as average speed. What is average speed and why do we need this term actually? Let me tell you. Let us suppose a person starts from here, say at point A, and reaches point B, right? And he is going by car, let us say. When he starts his journey, okay, his speed at this point, say up to C point, his speed is 20 kilometer per hour. Why? Because there was traffic when he was going from the normal Indian streets. Naturally, there is traffic in the morning. Okay, so it's 20 kilometer per hour for a very short distance. Then the road was empty. Road was having no traffic. That's why his speed was somewhat higher, say 60 kilometer per hour. Then at another point up to D, it was 60 kilometer. Then from D to B, there was some traffic. He reduced his speed from 60 to 40 kilometer per hour. Now if someone says and someone asks, what is the speed of this person from A to B? You cannot say a single word that his speed was this much. Why? Because his speed is 20 kilometer for distance from A to C. Then from C to B, he was driving his car at 60 kilometer per hour. And from D to B, he was driving his car at 40 kilometer per hour. Now this is somewhat complex thing, but let us make it simple. When you don't know how much speed will be there in this type of journey, then you take a term known as average, right? What is average? Average means take this speed plus this speed plus this speed and divide it by 3, right? Then this speed 100 plus 20, 120, so it is 40 kilometer per hour. Now I can easily say that the average speed of the person from A to B was 40 kilometer per hour, right? So when we are having a journey, having you can say a kind of a path where you are following the speed in such a manner that it is not uniform, it is changing after some short distance, then you need to take some another word other than speed, and that other word is called average speed, right? Because we take average of these. Okay, so 40 kilometer is the average speed. I think now you understood what is the need of taking average speed, right? Then there is another term which is known as velocity. What is velocity? In last lecture I told you that two type of quantities, physical quantities are there. One is scalar quantity and other is vector quantity. Scalar quantities are those which are characterized or which are having only magnitude, mean only magnitude is required to explain them. And what are vector quantities? In which both magnitude as well as direction is required to define these quantities, then these quantities are known vector quantities. Now velocity is nothing but speed with a direction. Speed with a direction is called velocity. Very simple. So it means if you generally say this is scalar and velocity is a vector quantity, right? So I will give you one example for this. Let us say you are saying this is north, east, west, south. Simple. If you forget how to, actually there will be a lot of questions when you will go to 11th class, or when you will study motion in even 9th class. You will have, or even when you go for some sort of competitive examination, then you come across the some questions concerning directions, right? So for directions you need to draw this. If you forget where is n, where is e, there is a simple method. This is NEWS, news, right? So north, east, west, south. You start from north, then east, west, and south, two arrows parallelly, right? And give a plus sign. So now this is say origin. Now if a person is going in this direction with a velocity of 40 kilometer per hour, now I can say the velocity of a person is 40 kilometer per hour along east direction, right? So now this velocity can be negative also, right? It can have a zero value also. But if you talk about speed, speed can never be negative. It is a positive quantity. Okay. So if you say 40 kilometer per hour along east, we can say from its origin that it will be minus 40 kilometer per hour along west. Just opposite direction, 180-degree opposite. So when you define some sort of direction with the speed, it is called as velocity. Nothing special actually. It is just a vector quantity. That's all. Okay. Sometimes we take velocity as average velocity, right? How to take average velocity? Let us say a person starts from here. When the person starts, now I'm going to tell you two terms, right? Which we will be using in numericals also. So just see it very carefully. When a person starts, his velocity is called initial velocity, right? And it is always denoted in motion as small u, right? Cannot change the symbols. These are given by the scientists when they are writing the books, right? They have decided that the symbol of initial velocity is u. Okay. And let us say he reaches here, starts from A and reaches here, and say his velocity at this point is called as final velocity, and it is always denoted by V. Okay, and if someone asks you now, what is the velocity of the person going from A to B? Now you are again confused. Don't get confused. Take a new term, and new term is now average velocity. Well, we call average velocity. So average velocity will be equal to average of these two, like u plus v by 2, right? This we will using somewhere in the numericals also. Okay. So this is the whole thing which I wanted to tell you about speed, velocity. So the next lecture is acceleration and retardation. This word actually, when student comes to class 8th or 9th, he or she listens to this sentence for the first time, this word for the first time. But let me tell you, you might have heard this word acceleration many times in your life. if you are driving by a car, or you are going by a car. So when you are sitting in a car, and you might have seen that if you are sitting with your father, then and you are driving, and he will say, please don't drive fast, put your foot away from the accelerator. He will use this word accelerator. What does the accelerator do? When you press the accelerator, velocity or speed of the car increases, right? So it means acceleration is nothing, but it is somewhat related with velocity. Let us see how. When we say acceleration, it is clear that it is related with velocity. So when you press the accelerator, velocity is increasing or decreasing? Naturally increasing. So it means velocity is increasing, right? Okay. Let us say your velocity at this point A is 80 kilometer per hour. Now you see there is no traffic. You put your foot on the accelerator, and then let's say up to this point, up to B, your speed is increased from 80 to 100. Okay, and then you see that there is some traffic. You slow down up to point C, your speed again decreases from 100 to 60 kilometer per hour. So what is the general observation? Here velocity is 80 kilometer per hour. Here velocity is 100 kilometer per hour. It is also velocity, say V1, V2. You just see velocity is increased, and from B to C, velocity is initially 100 and finally 60. Now what is there? Velocity is decreased. When something increases or decreases, we use a word for increase or decrease, and that word is called change. Okay, so it means we can say that from A to B and B to C, there is change in velocity. That is clear? Okay, so this change in velocity per unit time is nothing but acceleration. Acceleration can be written like this: A double C raised to power n, or you can write full. It's your wish. So we have defined what is acceleration. Rate of, when you divide something by time, this whole word is called rate. Rate means how with the time this numerator changes. This is called rate. Okay. So what is acceleration? Acceleration is the rate of change of velocity. How the velocity is changing with time. It is sometime increasing, sometime decreasing. Okay, when we say it is increasing, then it is called acceleration. And when we say the velocity is decreasing, then this acceleration is also called as retardation. Retard mean to get backward. Okay, so retardation will be there, or it is also called as negative acceleration. Retardation has another name called as negative acceleration, or one another name, deceleration. I will give you one example where you will see that things are changing with motion in a sense that it will be somewhat the beauty of physics. You know, physics is actually full of the things which gives you a sightseeing experience. Like, I will give you a simple example. Let us say we have a ball, right, in our hand. So there are two positions. I'm standing here, right, like this. I take a ball and I throw this ball upwards. Okay, so this is ground where I'm standing in this room. This is the ball which I have sent in upward direction. I just threw it away, right? Okay, in the upward direction. the ball will go there and at a certain time it will come back. Okay, that is normal. Do you know why it will come back? Anybody knows? Yes, you have heard. Newton's life was changed after this when he saw apple falling from the tree. What was that? Gravity. So this ball is coming towards the earth due to gravity, right? Now listen to me carefully. I'm going to connect this acceleration with something with gravity, because in next chapter of ninth class or in higher classes you will come along with this chapter, gravity and gravitation. It is connected with this. So listen to me carefully. So this ball is coming down due to gravity, right? Now when I threw this stone in upward direction, where was motion? Motion was along this direction and gravity was along this direction. Okay, you are sending this stone upward, but gravity is along downward direction. Actually, this is not gravity. This is acceleration due to gravity, right? Now you will say, what is acceleration? Change in velocity. I told you. Now change in velocity is if the motion is like this on a horizontal plane. This is normal acceleration, or if it is negative, it is deceleration. But when the body is falling like this from upward to downward or downward to upward, then this is called as acceleration, but due to gravity. Now okay, I have a pen, say this one, and I am throwing it. Now at this point, what is the velocity? It is at rest. Okay, it starts from rest u0, and when I will just keep it loose, its velocity will increase until it reaches the earth. So from here velocity is low, and due to gravity pull of gravity, its velocity will increase. So there is change in gravity when it is going downward, and change in velocity is called acceleration. So acceleration is there when body is falling from height to ground, but that acceleration is only due to gravity, right? So there are two types of acceleration terms used. When the motion is on a plane, horizontal plane, then we simply use the word acceleration. But if the motion is upward or downward, we use the word acceleration due to gravity. So now in this case, motion is upward, but gravity, acceleration due to gravity is downward. Just see the thing. And if I am on a top of a roof and put the ball like this, the ball will come down. Okay, this is motion. Where is gravity? Acceleration due to gravity is also downward. So if I throw a ball from the top of a roof, then the direction of motion and direction of acceleration due to gravity will be same. If I throw a stone in the upward direction, direction of acceleration and direction of motion will be opposite. It's a very simple example. So acceleration in general terms means change in velocity per unit time or rate of change of velocity. Is that clear to you? I think it's very simple. It is not a rocket science which you need to go by some difficult phase. Okay. So now what is the unit of acceleration when you measure? Like unit of speed is meter per second. Okay. What is the unit of acceleration? Very simple. You can find the unit of some quantity by using its formula. Very simple. Acceleration ka formula what is? Change in velocity per unit time. What is the you can say the what is the basic unit of velocity? Meter per second, right? Okay. What is unit of time? Second. So the unit of acceleration will be meter per second into second, second square. So just remember that unit of acceleration is meter per second square. Okay. Or if it is in kilometer, then you have to take kilometer per hour square. Okay, so in acceleration, there is 2 power of second square, because in velocity it is displacement upon time. Displacement unit is meter, time second, and again time, so second square, so it become meter per second square. Very simple thing, nothing new. Okay, now there is a word uniform acceleration and non-uniform acceleration. Uniform acceleration and non-uniform acceleration. What are these? Very simple. In last lecture, I told you what is uniform motion. When the distance covered by an object is equal in equal interval of time, motion is uniform. Simply when I was telling you about distance, then we were using the word distance. Okay. But what is acceleration? Change in velocity. So now I will use the acceleration will be uniform. Acceleration will be uniform if change in velocity is, yeah, or velocity changes in equal intervals of time in equal amounts. Like if I say the change in velocity. So our next topic is graphical representation of motion. Though I have done this in previous lectures also, if you have seen the lecture motion, I have drawn some graph. Similar is here. What is the meaning of graphical representation? Actually, when we want to interpret some data, right? We have some data, like at this time person was here, at this time person distance was this much, at this time person distance was this much, then we can draw a graph between distance and time. Similarly, from that data, if we have some other data, like a person is having velocity at this time, velocity at this time, velocity at this time, then we can draw a graph between velocity and time, right? Or sometimes we can say that find out something from this graph. What can you interpret from this graph? What can you deduct from this graph? What can you explain if you see this graph? Can you explain the motion? What was type of motion? What was there actually? What is actually happening in during that motion? So that is called graphical representation of motion, means simple graphs where we define some sort of motion. So there are generally two type of graph, various type of graphs are there, but at 9th or 10th level, you will be having two types of graphs. One is distance time graph and other is velocity time graph, right? One is distance time graph and other is velocity time graph. Okay. So to start with, what is velocity, what is distance time graph? Actually, we did it in our previous lecture, but let us repeat it here for the new users of this channel. Distance time graph. Let us say there is a data. A person is changing his position with time, right? Because changing of position will give us path length, right? And path length is nothing but distance. Okay, with time his position is changing. So let us say there is time and there is distance. Okay. So time is, say, 9 a.m. Distance covered was 10 kilometers or 0 kilometers. Then 9:30, it is 10 kilometer. Then 10 a.m. it is 20 kilometers. And then 10:30 a.m. it is 30 kilometers. And 11 a.m. it is 40 kilometers, right? Now we just draw a graph and let us see what we can find from this graph. Okay, I told you that there are two type of quantities. One is independent quantity and other is dependent quantity. Clearly, the distance is depending upon time. Time is not depending upon distance. We always say that distance depends upon time. At this time, distance was so much, and this time, distance was so. Distance depends upon this, and so it is independent quantity, and every independent quantity is taken on x-axis. I already told you in general terms. So we take time here in seconds, and here we take distance, right? It is region O 0, so it is 9. It is, or 9:30, or we take it as 9. It is 9:30. It is 10, 10:30, and 11. Here you take 0, 10, 20, 30, 40. You just draw a graph. When it is 9, it is 0. Okay, 9:30, 10, this much, and then 20 at 10, and at 10:30 it is 30. Okay, and then 11 it is 40, right? So when you just join this, it comes out to be a straight line. Actually, whenever the motion is uniform, this is a uniform motion. I've told you earlier. So in uniform motion, equal interval of time, equal distance is covered, like 10, 10, 10 in each 30 minutes, right? I've told you earlier also. What is new in this, in today's lecture? That is a new term known as slope. Okay, sometime in class 9 they do not tell you what is slope. Okay, let me ask you this question: what is slope? Have you heard this word slope, or have you seen some slope anywhere? Yes, whenever you go and you see there is a kind of slope, in your school, where when you are at your home, and at the entrance of your home there is a slope like this, and you can just take, but slope means it is not horizontal, it is at inclined at just angle. This is slope, right? So how much this line is inclined gives you slope actually. But we can find in the terms of coordinate geometry. You must have done your coordinate geometry in ninth class also, mathematics. That is simple. But let me tell you something new. Okay, let us say this line is there, and this is x-axis, this is y-axis. I'm telling you how to find slope. Okay, very easy. Take any 2 points. What I'm telling you, to find the slope of a line, how much line is inclined, that is slope, and to find that slope you take any 2 points, it's your wish, on that line, and draw the perpendicular on x-axis and y-axis, x-axis and y-axis. Name it. It is x1, it is x2, it is y1, it is y2. Now simple formula of slope in the terms of coordinate geometry will be equal to this minus this divided by this minus this, y2 minus y1 upon x2 minus x1, right? This is the simple formula of slope. Now come to this. Let us take any 2 points. It's your wish. Either you can take these two, or leave. Take new points, 1 and 1. Draw perpendiculars. This and this. These perpendicular will touch distance axis and time axis at some points. Okay, let these points be T1 and T2. You can measure it. If you know it is 9:30, it will be 9:40. Or, and if it is 10, it is 20, it will be 15 approx. So you can find it, but we are taking general terms, and right, it is distance, say S1 and S2. Okay, now what will be the slope of this distance time graph? What will be slope? Y2 minus y1. Just look at this. Y2 minus y1 divided by x2 minus x1. So s2 minus s1 divided by t2 minus t1. Tell me, what is s2 minus s1? Distance. What is t2 minus t1? Time. What is distance by time? Speed. you know. So, what did you find? That if you are having a distance time graph, take its slope. What you will find? Speed. It's very simple, very astonishing that if you have a distance time graph, if you have a data of distance time graph and you don't have speed, don't worry, draw a graph between these two, distance and time. Take the slope of the line using this coordinate geometry formula and you will get this thing as speed, right? So always remember that the slope of distance time graph you can find speed. Okay, is it okay or not? Okay. In similar terms, if it is not distance, it is displacement. What is this? Displacement. And it is time. Now in displacement time graph, if you take slope, what will you get? Velocity. Because now in place of distance, you are taking displacement. Distance is scalar, displacement is vector. So displacement upon time is what? Velocity, not speed. Distance upon time, is speed. Displacement upon time is velocity, right? So this is the beauty of a graph, that you can find the speed or velocity by using distance time graph or displacement time graph by finding its slope. Simple slope of any distance time graph will give you speed of that object. Okay. So our next topic is velocity time graph. Okay. So this velocity time graph will be divided into two types actually. Okay. When there is no acceleration, acceleration is zero, and when there is uniform acceleration. Let me tell you what does this mean. Okay, let us say an object is there. Anything can be there, any object which is moving. And let us say this object is moving in such a way that it is having a uniform velocity. Say from this point A to this point B, this velocity is 30 kilometer per hour, right? Okay. So, and let the time from A to B is say not 1 hour, okay, 1 hour, right? So, it is simple that velocity is 30 kilometer per hour and total time taken is 1 hour from A to B. If we write it in the form of a data, then we can write like this: time and velocity 9 a.m. mean at this point, say 9 a.m. he started his journey. Velocity is 0 kilometer per hour. Okay. And at 9:30 his velocity was 30 kilo, not take it 0, otherwise we will have a graph like this. Take it 30 kilometer per hour. 9:30 it is 30 kilometer per hour. Then 10 a.m. it is 30 kilometer per hour. 10:30 it is 30 kilometer per hour, and 11 a.m. it is 30 kilometer per hour, right? So if you draw a graph, just look at the graph, it will be very different from the what we see, what we are actually imagining. So this is time, this is velocity. Okay, velocity is okay, and this is time, right? Time is 9, 9, 9:30, 10, 10:30, 11. What is velocity? 30. So that 10, 20, 30. Okay, at 9 it is 30. At 9:30 it is 30. At 10 it is 30. At 10:30 it is 30. At 11 it is 30. Okay, join these. What type of graph you see? It is a line parallel to x-axis. It's very strange. It is clear also that at any time you see that velocity is 30, 30, 30 and so on. And you know what is acceleration? It is change in velocity. Bro, you can see here, velocity is not changing at all. So it means there is no acceleration because no change in velocity. There is no change in velocity. So no acceleration. And under this scheme, the graph will be like this. Now I am going to tell you something very important, okay, which is area under a graph. Area under a graph. Can you find area under the graph? Yes, very easy. Take any 2 point, say this one and say this one, some new point, no problem. But it should be on the line. This one. Draw perpendicular on x-axis only. Draw perpendicular. This area is called area under the graph, right? This area is called area under the graph. Can you tell me what type of figure is this? Rectangle. What is the area of rectangle? Length into breadth. What is length? This much. You can find out. How? You can find out. Data is there. This minus this. This is this length. What is breadth? Fixed. How much? 30. This is 30. 30, 30. So 30 into this. This is say T1 and this is say T2. So 30 into T2 minus T1. If you want to find this length, we have to find T2 from here to here, T2, and from here to here it is T1. So T2 minus T1, this length minus this length will give you this, because all distances are measured from origin. So it will be this minus this. You will get this T2 minus T1, length into breadth. What is breadth? 30 kilometer. So length into breadth. This is length, this is breadth. What is this? Area. Which area? Area under the graph. And you know what? What is this actually? Can anybody tell? No, because you are not revising the syllabus. Oh, just look at this. What is 30? It is velocity. Okay, velocity into what is T2 minus T1? It is time. Whether it is T2 minus T1 or only T or whatever it is, it will remain time only. So velocity into time. What is velocity into time? Now you will say, sir, we have not heard about this formula. Arey bhai, it's very simple. You know what is displacement? What is velocity? Displacement upon time. So velocity into time, if time goes there, what will get? Displacement. So velocity into time is nothing but displacement, magnitude of displacement. So now we have concluded that area under this curve, which is 30 into T2 minus T1 due to length and breadth, is nothing but magnitude of displacement. So we can conclude that area under a velocity time graph will always give you what? Magnitude of displacement. Remember it. What did I say? Area under a velocity time graph will always give you magnitude of displacement. Is that okay? Clear? Now we come to a case where velocity time graph will be drawn where the body is having uniform acceleration. What is uniform acceleration? I just told you in today's lecture. If the change in velocity of a body moving in a particular direction is having equal amount in equal interval of time, right? Like for example, I take a data, time and velocity time is 0, velocity is 0, time is 5, velocity is 10, time is 10, velocity is 20, time is 15, velocity is 30, time is 20, velocity is 40. Just see, in 5 seconds or 5 hours which you take, velocity is 10 minus 0, 10. From 5 to 10, it is change of 5 seconds. In 5 seconds, the change in velocity is 20 minus 10, again 10. In next 5 seconds, 15 minus 10 is 5 seconds, you see that change in velocity. Now 30 minus 20, again 10. In next 5 seconds, you will see that change in velocity is 40 minus 30, again 10. So the change in velocity is equal in equal interval of time. This type of motion is under uniform acceleration. Now the acceleration is uniform. Okay, it was a similar case. In that case, we said it covers equal distance in equal interval of time. That is uniform motion. But now it is uniform acceleration. And how acceleration is produced? By a change of velocity. That is why we said change in velocity should be equal in equal interval of time. Right? Then it is called uniform acceleration. Let us see the graph and its magic. This is nothing but time. You know now time is taken off on x-axis. Why? Because independent parameter. This is velocity. Draw a graph. Time is 0, 5, 10, 15, 20. This is 0, 10, 20, 30, 40. You know 0, 0, 5, 10, and this much 10, 20, 15, 30, and 40. So graph will be a straight line. Clearly straight line. Whenever there is uniform motion, I told you in previous lectures, this quantity varies directly with this quantity. And if any quantity varies directly, it is directly proportional, then the graph will be a straight line. Remember, always remember, if any quantity in a graph on y-axis varies directly with the quantity on x-axis, their graph will be a straight line without any doubt. Okay. So now let us see what we can find from this graph. Can we find some area under the graph? Yes, let us find how. Take any 2 points. Okay. Draw perpendiculars. Now you know this area is called as area under curve, area under graph. Which graph? Velocity time graph. Now what is this area? This area can be found by 2 methods. It is a trapezium and its area is half into sum of parallel sides. This you can find from this and this, sum of say AB, and this is CD. So AB plus CD into distance between these two, this much, BD. This is area of trapezium, and this will give you nothing, again, magnitude of displacement, because area under velocity time graph always gives you magnitude of displacement. So it is nothing but S, right? S means displacement magnitude, magnitude of displacement. There is one another method to find this area. Join like this, okay? Draw a line like this. Now find the area of this triangle and find the area of this rectangle. Add these two areas, you will get the area of total area. Again, it will be magnitude of displacement. Why? It's very simple again. What you are finding? Area. Okay, there are 2 quantities. One is velocity, other is time. It means you are basically multiplying these 2 quantities. Again, area in, whether you take area of triangle, half into base into height, base into height, again, and in this case length into breadth. Okay, every time you are multiplying velocity into time, But what is velocity into time? Velocity into time. Displacement. कैसे? This one. Velocity is equal to displacement upon time. So velocity into time will be equal to displacement. So this area gives you nothing but displacement only. Magnitude of displacement. So displacement equal to this much area. You can find the area of trapezium, or by dividing this into triangle and rectangle, you can find the area. Okay. So thank you very much for the patience hearing. Tomorrow I will post some other things in this unit, and that is, I suppose, equations of motion. Very easy to understand, and that equations will actually depends upon this type of graph, velocity time graph. That's why I told you. Okay, so thank you very much, and it's my humble request to you, please share this video as much as possible, so that the knowledge can flow from you to others, and in your friend circle, and in your teacher circle, or in school, or in college, wherever you study. You just go and tell them that it's very easy to understand motion by using these methods. Okay, thank you very much.